Hello everyone, my name is Siddharth and I am a first year graduate student from the Department of Chemistry and Biochemistry. I work on separation chemistry in Dr. Armstrong's lab. My topic for the poster is overcoming the challenge of complete isomeric separation of alethrin, a three-column approach. Insects comprise of about 72% of all animal species and are responsible for various vector-borne diseases in crops, livestock, and humans. Annually, about 2.7 million deaths are caused by mosquito attacks. Several insecticides, like the synthetic pyrethroid alethrin, are used commercially for mosquito control. However, the use of insecticides can have negative effects on human health and the environment, as residues may be left behind. Alethrin contains up to 8 stereoisomers that have varying levels of biological activity and toxicity. Therefore, it is essential for companies involved in the synthesis and distribution of these insecticides to accurately control the stereoisomeric composition of their products. I will discuss about the method developed to separate the stereoisomers of alethrin. Alethrin has three chiral centers and thus has 8 enantiomers. The cis and trans isomers got separated on a C18 column. Complete diastereomic separation was observed on a hypercarb column, but it was not baseline separation. Plot of retention factor K versus percentage acetonitrile showed that baseline separation is not possible in a reasonable time frame. So, peak fit software was used to show baseline and find concentration. Enantiomeric separation was done on a CD shell RSP column, but the first peak was not resolved. However, the CD detector showed that the first peak was an enantiomeric pair. Chiral pack IC column showed selectivity for all the enantiomers but could not attain baseline separation. So, we concluded that a single column would not separate alethrin efficiently, and thus collected the unresolved peak and resolved it on a chiral pack IC column. In conclusion, all enantiomers were separated using three columns. The hypercarb column successfully achieved diastereomic separation. The CD shell RSP column achieved enantiomeric separation for all except the first enantiomeric pair. Finally, the chiral pack IC column was able to resolve the first enantiomeric pair, completing the separation of all alethrin isomers. The developed method can be applied to a 2D HPLC in the future. I would like to thank JASCO for providing the RHPLC and AZIP LLC for providing the columns. I would also like to thank Dr. Farooq Wahab and Dr. JT Lee for guidance and supervision.